if you missed this one, we did this last Tuesday, guys. Okay, so this was the practice for doing this programming assignment, this one. Okay, so please watch the video. I posted the recording already. Okay, so please watch it again. And even if let's say whenever you forget the process, you can rewatch it as well. So this practice one is really similar to this programming question. So this will really help to do this in particular. Okay, all right, so let me go back to the one that okay. Okay, so so this is our problem statement. Okay, what are the inputs? Yes. Okay, length, width, anything else? Angle of rotation as well. All right. So how did we recognize them as inputs? Okay, or in other words, what part of speech that say that they are inputs in that problem statement? Yeah, that's the word given. That the single word given tells you these are the things given to you, right? These are your inputs, right? So, and we call these verbs with words vocab words in problem solving. Okay, because that's the important vocabulary that recognizes the inputs given to you, right? Sometimes they are really explicit like this, like given, provided, or just input itself. But sometimes they may be hidden as well, right? So but these kind of some, at least some kind of a wording, they are recognizing an input in a problem statement given to you. Okay, so try to isolate using that, try to isolate the inputs using that. Okay, all right, so now I'm gonna copy paste that. So it's part of the umpire process, right? So I'm gonna copy paste that and then write it over here. Okay, so those are inputs. What is the output? Yeah, so basically this is the output, a rectangle, right? So that's the output. So it's basically a drawing of a rectangle. That's the output, right? Okay, all right. So and you can see that, right? Sometimes I mean this in particular is not that of a difficult problem, right? Imagine it's a really a long problem statement, and then isolating like this going to help you, right? Because then you don't have to reread your problem statement, right? Okay, so let's go now. So next step is to do an example, right? So this is a drawing, so we can actually draw an example by ourselves. Okay, so I'm gonna go over here into my Excalibur and I'm gonna use it over there and then try to draw it. Okay, all right. Okay, so all right. So where is the turtle usually in general? At the origin, right? At 0 0, right? 0 0, and it's at actually looking at east. Okay, so what should I first do here? Well, before that, so basically I mean I said something over here, right? I mean you're right, we have to draw first line, but there's something we can do before based on our problem statement, right? It says right here, right? The smallest counterclockwise angle to a side from a line parallel to the x-axis. It basically actually saying is that we actually going to draw not just along, you know, east-west line. You're gonna go turn an angle and then draw. Okay, so basically saying that we need to first turn an angle, right? Let's say like like 45 degrees, and then now it's gonna basically move facing towards that angle, right? So now we're going to start drawing. Okay, so now what do we do then? So yeah, we turn by an angle. All right, so that's the angle of rotation, right? So what do we do now?
Now we go straight.
Yeah, move forward by what?
Is it given? Does it want it specifically? It just says given this. So can I pick?
Yeah, so basically now it's we go the length, right? So I'm gonna write L over here for length. All right, now what we do? So now the turtle is looking at somewhere like northeast, right? Northeast, this way. So what do we do?
Turn another 45.
45 or something else? We are drawing a rectangle. Come on, we are drawing a rectangle.
The negative 45, whatever that is. Am I confused on the 45? Is it 90? Oh, 90. Yeah.
It's 90, right? Because it's a rectangle, right? So we are, so after this initial turn, we just use 90 degrees. So basically this is going to be like this, right? Okay, so this is, going to be 90.
The assignment itself is asking us, we're not just drawing a rectangle, we're drawing a rectangle that looks
Yeah,
some
yeah,
angle of
yep. Okay, all right. So now we go. Now what do we do?
Now we go straight for the width.
Yeah, width, right? So I'm gonna write this like W width. Okay, so now we are looking at this way. So what do we do now?
Now we turn 90.
Another 90, right? So basically this way, and then we're gonna turn another 90, right? So and then we turn look at this way now, right? So imagine, like, when you do so with actual pen, you may even use technology like paint as well. You will realize what your turtle need to do, right? It's really important that cognitive thing happening inside your brain, it's actually really working when you actually do so. Okay, so that's the power of working couple of examples. Okay, so in this case we are drawing. So now we can move forward again, right, by the length, right? So that's the length, and then we are looking this way, right? And we need to turn again, right, by 90 degrees. So we are looking this way now. Now we can move forward and come to the original location, right? So these are all 90 degrees. Okay, okay, all right, and this is also width. Okay, and that's it. That's what we have to do. Okay, so now what we have to do is, okay, so we have to write these actions in English, right? So I saw that the other day, some of you guys directly jumping into writing code. Okay, I highly discourage that. Okay, so the reason is, one reason is, when you try to do so, you will do a lot of brute force, like, because we are trying, you are having to try a lot of trial and error things, and that's also frustrating. But when you design your solution first, it's easy to translate from English to actually code, because we are learning the syntax of code, right? So um, so this is the most straightforward way to your answer is actually, first designing it and then translating from English to Python. Okay, all right, so let's write our plan then. Okay, oh, okay, so there's a match for this one, right? It's really good match for this problem now. What is that? That one, oh yeah, that's also this one, draw triangle, right? The draw equilateral triangle problem. That's a really good match, because instead of a triangle, we are going to draw a rectangle, right? So that's all. Okay. So okay. So let's write our steps. What should be the step one?
Turn that first 45 degrees.
Before turning,
Put the pen in.
pen already down, so you don't have to write it. Actually, by default, pen down. So well, let's say you are making a bread. First, what do you do first?
You have to establish what the length of the width are.
Forget about
For
that. So,
bread, we gotta get the ingredients.
yeah, so collect the input, right? So inputs. So what are we inputting? Input all of these, right? Width, length. I'm gonna copy paste. Okay, guys. Input. I'm gonna change that to appearing like code. So I'm gonna say like comma and then angle of rotation. So I'm gonna change this to variable names. Okay. Okay, so that I can actually copy later on into code actually directly. Okay. So input this, right? It's like, you are putting the ingredients now into your bread machine. Okay. All right. So 2. Now we can follow our diagram and then think about what we did, right? So first we rotate left by this angle, right? So left by what?
45.
Yeah, that's the value there is 45. That's an example. What is it in here in the input?
Any rotation.
Yeah, what's the value in here?
Angle
Angle of rotation, right? That's that. Okay, by that. Okay. Okay. All right. Next step 3.
Forward by width.
Yeah. Yeah. Forward by length. Next step 4.
Left by angle of rotation.
Yeah. No.
Because now it's a new.
So left by, yeah, left is right, correct.
So now we can just say 90.
Yeah, left by 90, right? Because we are drawing a rectangle, right? Yeah. Okay. All right. 5. Then forward by again. So I can now copy paste some of these, right? Or maybe I can go forward by width. Okay. So all right. 6. Left again, right? By 90. Now I can copy paste this. Okay. I'm going to copy paste because we are repeating. You can see that 4 times, right? Like right here, right? So I'm going to copy paste and change the line numbers. This is 7, 8, 9, and I think, yeah, 10. Okay. All right. Malia, let's get going. Okay. Try to follow me. Okay.
Do we need that final left by 90?
I think you're right. Yeah, we don't need that. Yes. 1, 2, 3, 4. Yes, you're right. So only need, yeah. Thanks. Okay. So this is our plan, and you can see that, right? It's actually a solid plan, right? So, and then try to make sure it actually works. And it should work, right? Because if it doesn't work, and we can actually come back and correct, of course, always. But if we should try to try our best to get the correct algorithm first, right? Otherwise, if our algorithm is wrong, then now we are solving a wrong solution, right? So that's not right. So make sure it actually works, right? So right. So and then we are ready to now actually translate this line by line. Okay. All right. So we collected the input, and then the translation of line 1 is already I have given to you guys. Okay, so this is that line. That's why it's line 1. Okay, see that input with length and angle of rotation. And this one I'm gonna take it as laser actually. Okay, so See that input function should come in as parameters, right? And that's actually the line 1, okay? And that's the collection of inputs right here. Okay, so it's kind of nicely matching, kind of, okay? So that's why you will see that in my when I do this on, always my collection of input at actually the very beginning, okay? All right. All right, so then basically we're gonna turn left by angle of rotation, right? So I have created my turtle over here, just need to replace this line with our code, okay? So all right, turtle dot, what should be that? So left by, right? Step 2 by angle of rotation. So it's this one, so I'm going to copy, put it over here. And by the way, guys, when you actually recognizes the input and when you write them down in your plan, write them as if that they are actually your variable names, so that you are ready to copy paste, because that way you save time as well. So basically directly can copy and paste, right? But make sure they are expressive, like the same way that I have written the angle underscore of underscore rotation, right? It has to be expressive, okay? All right. Okay, so that's step 2. Step 3 then, oops, sorry. All right, move forward, right? Forward by how much? Yep, length. Next one, step 4,
Turn
left, right?
left.
By how much?
90.
90. All right, here's my question. This 90 here, right? Why it is not an input here?
Because it's the same every time. Because it's the law of rectangle.
That's one reason. There are other reasons. Anyone? Yes? Um, don't get confused with input function. Yeah, that's what they are. He also said. Yes, there's one more answer as well. Explanation. Why 90 is not an input? Like, see that it's not there on the top, right? I don't have that angle as an input over there. Angle of rotation is the first time angle we rotate. That's it. Then it's always 90 94 times, right? Right. My question is why that 90 is not coming as an input?
Well, we never want that to be something perfect.
Yeah, why?
Well, if it's not 90, it's not rectangle.
Yeah, we are drawing a rectangle, right? So that's the domain knowledge, right? So that's basically a fact. 90 here is a fact, right? Because we need that to draw a rectangle, right? So that's part of the domain knowledge. And also because we are drawing a rectangle, we don't need to pass it as a 90, like 90 as an input to a function, because we can take it as a value inside our code. And that's what I have done, okay? All right. Okay, now move on. So the rest of the steps are similar kind of. So I'm going to copy paste and change, guys. Okay. So this is going to be, so step 5 and 6. I think this is going to be width though, right? Okay. And now we can, copy paste the whole thing one last time. And I don't need this line, right? Okay. That's it. Okay. All right. And then this is the translation of all these lines. Okay. And one more tip, guys, whenever you write your algorithm, each line, begin that line with the verb, respective verb, right? So in this case, like, turn left, move forward, that's kind of, I actually remove that part, but imagine it's an action, right? Each code line is an action that you are doing, so you better put the verb to the front, right? Bring the verb to the front. Okay. All right. So all right, so that's, I think we are ready to run this one. So I'm going to make sure everyone has this code. Are we ready, guys?
No, I'm not.
Okay.
Kind of stuck with
Who else having problems? And then our TAs can come in and help you guys. Okay.
okay. The copy of the sentence comes out right.
So I'm gonna yeah. All right. Before we run, may I ask the so let's go to this bread machine thing, right? So here's my question. Um, I did this. Let's say I am the engineer. I did this. I solved the problem. Okay. With the analog to the bread machine thing, what is this process? Anyone? Yeah, the recipe or I mean, you're right. Basically, if you take the analogous physical example, this is the making of the bread machine, right? Right. So we implemented the function. So this is like, making you are the engineers building the bread machine, right? Okay. And then the user going to basically use the function. That means user going to use the bread machine, right? That's gonna come in the main program. Okay. Remember, guys, in this class, I said this last week too, right? You are all three. You are the engineer who write code, and you are the tester and user also the same, right? So try to get into the particular shoe right at the moment. Okay. Like for example, when you write the function, you are the engineer solving the problem. Then when you call your function, you are the user or the tester. Okay. All right. It's really important that you understand the difference between the three. Okay. Otherwise, kind of you may feel like confusing if you do not understand that. Okay. All right. So I'm going to call this function. All right. So all right. And well, sorry about that. I missed something. All right. So now I'm going to use my bread machine. So what do I need? I need the ingredients, right? So I need my inputs, right? So with, well, angle of rotation, let's say it's 45. We actually use the 45 as an example, right? Okay. So with, let's say like 60, right? And then a length, let's say 100. Okay. So this is like, I'm collecting my input. So it's exactly similar to you are collecting your input so that you can actually, your ingredients so that you can use the bread machine. Okay. So right, so now we're gonna actually use the bread machine by calling this function, right? So this is the usage or call to our function. So now we have all three ingredients with length, angles, and these are the three values, right? Okay. So I'm gonna run this one. All right. So length. Okay, I think I made a spelling mistake, right? Line 40. Yeah. NGTH. Yeah. So this has to be here as well. All right. All right. There you go. Okay. And this is the 45 angle, and then we have drawn the rectangle. Okay. Let me know if you if you have problem getting in here. Okay, guys. So that's the basic problem. Okay, so always try to solve the easiest of the solution. Try to get the easiest of the solution, and then you can add features or add more things to get more complicated tasks. Okay,
Okay,
it's always
so think
easy.
about this. If we're using
Okay,
90, so we assigned the variables. Not what would these be called?
so this is our function code,
These are
right?
the function codes.
So it's like you are building your bread machine. You are the engineer. Now here you have actual values. So you have the ingredients, real ingredients to
And
use
that's
the
inside inside
that's
the
inside
main
the main
function.
program. Yeah, because when we run this program, you should call the main program. Okay,
Oh, okay.
that's why. Okay.
So kind of giving the instructions first, and then using those
Yeah,
instructions, taking
yeah,
exact
you can think
values.
of that. Yeah, as well. Yep.
Sort of.
Yep.
I'm trying to think of it like bread.
Yeah, it's good to have analogous value. Yep.
So what are you doing right now? Where's the module we're doing right now?
Module 4.
I know four, but
Rectangle. Draw rectangle problem.
Here's my rectangle. It says unbound local area.
Okay, I think I know the answer. So line 26. Let's go to 26.
This
Okay.
one, it was the
Yeah. So the reason is this, right? So you actually use the function before you defining your variables, right?
so
So
the
this
variable
has
just
to
being like
come after this line 29. So cut it and then paste it after line 29.
oh, I see what
Because code run top down, right?
right.
That's
Right,
why.
of course.
Yeah.
Oh, I see what you're saying.
Yeah. So now adjust. Yeah, now it should run actually. All right, so now there's another one. Yeah, so there's three given. So I think the reason is I can show
For
you
the
the
color,
reason.
right?
Yeah, yeah. Remove the color. Yeah,
Like, or
yeah.
just add color then, right?
You can let me see the top. Yeah, you have color, and then you can basically remove that for now. I'm gonna get into that real quick. Yeah, yeah. Remove the comma as well. Yeah,
Oh, I see what you're saying.
yeah.
Okay, so
Okay, turtle with no attribute begin. Okay,
was I
so
add the color
it should
on
be begin underscore fill,
begin underscore?
begin underscore fill, and end underscore fill. All right. So I'm gonna add color also as an input, guys. Okay. So follow me. Okay. So I'm gonna add color now. All right, real quick, and from over here, so it's a turtle and fill color dot. Sorry, begin fill, fill, and then at the in the end it's actually end fill. Okay, end fill, and then after this line you basically this should be fill color, and then the input to that is color. All right. Okay, so now we can add a color over here. So I'm going to pass red. Okay, and rerun, and then we'll draw a rectangle with red color. Okay. All right. All right. All what I did was add another input called color, and then I changed that to see that I've used that color, and over here I have the specific value for ingredients like input color red. Okay.
Can you tell me why mine's just not? It's not giving me an error. It's just not showing me the rectangle.
Um, let's see. Um, it's not giving you error. Oh dear. Okay. Maybe your pen is the up. Let's see. No.
You didn't call function.
Oh, you didn't call the function. Yeah.
Okay, cool. So
Yeah, you didn't call the function. See, you implemented the problem, right? But you didn't call the function.
and
So you have to have it after this
After-
after line 63.
okay.
Line 63, yeah.
And how do I call it?
Um you basically, so it's the function name, right? So so it's like this. Like this line 59, okay? But I added new parameter, okay? Yep. Right here.
And wait, what was it? It was draw a rectangle. Oh. Oh. Draw a rectangle.
Okay. All right. So okay, now to draw the pattern, right? So what we can do is all right, I'm gonna call this. So basically, imagine this. I made a French bread. Now I'm going to make a Italian bread, right? So we're gonna call with a different ingredient, right? So for example, I'm gonna draw another rectangle with now the angle of rotation is different. Let's say not 45. We gave 45 right over here. I'm gonna give it like 90 degrees now, and also a new color, let's say blue, right? So let's try this one out, right? So so we're gonna draw actually two colors, okay? And you can see that now by repeating this you can actually draw that pattern that I asked you guys to try, right? So we're gonna basically repeat the code 6 more times, right? And then we'll get there, right?
So there's no assignment for color. I'm just putting the color that I want in quotations.
Yeah, that's fine. Yeah, yeah, yeah. You can directly do that. You can directly pass the value. Okay. All right. So I'm gonna copy paste this and change this value. Yeah. Right. All right. So this has to be now 135, right? And then I think 180. Let's see, 35, 180, and then 215, right? And then 270,
I think it is turtle dot begin.
315, and then 360, right? And that should be enough, right? So I'm gonna, right? And you can see that, right? So the power of you know using the function, right? So this can, like you can imagine, like we use the bread machine to create several breads, okay? So that's kind of the analog we have, okay? So let's run this one, and we have this, okay?
Do you know for the begin fill, does that need to appear twice or? Because now it is giving me an error message on 30.
Yeah, well, let's read there again. Okay, let's read there again. All right, see, begin field takes exactly 0 positional arguments, one given. So basically, you are giving a parameter that it should not have. Let's take a look. Okay. So see that begin field, it should be empty.
Okay.
You put color in there, right? That's why. So that's what it actually. That was the error message actually,
And
right?
and so the reason I put color was because
Yeah. Then it's not colored because you are not using field color, right? See my code, right? So after begin fill you need actually fill color, right? So this one you're missing this line, that's where you enter the input. Okay. All right.
I'm still not getting it colored, but it's not giving me an error message.
Yeah, let's see, maybe okay, so color, so yep, blue. So fill color. Oh, you are not ending the, so you need to have end fill right at the end, so that's why you have to end it. See that I have it.
Oh yeah. And then so if I want the multiple,
So you call, yeah, you call for different values. Yeah. Okay. All right. So right here, right? So this should be the next angle. This should be the next angle. Likewise. So we get this pattern, right? Okay. Okay. All right. So let's answer these 4 questions, guys. Okay. I will post this question after the class. Okay. So I will post my solution. Sorry, after the class. So let's answer the 4 questions. Okay. All right. Name a data type you use in your code. Name a data type you use in your code. Yeah, integer is one. There are others, right? Yes. String is one. Yes. There's one more type. Okay. So basically, this value is integer, right? So that's a data type. This value is a string, this text type or string. But this one also, right? This is also data type. It's turtle type. Okay. That's also a type. So the type of that turtle is actually turtle. It's turtle type. That's also a data type. Okay. So this guy is also in turtle type. It's a turtle. So type is turtle. Data type is turtle. This is this one. Okay. So here's integer. Here is text or string, and here's turtle type. Okay.
and can you define expression again? Like, are all of those expressions, or is it an expression on either side of the equal sign?
Well, basically, a statement usually made of a bunch of expressions. So this is a statement, right? So this is a statement, right? Assignment statement, right? So yeah, this one is a variable name. This is a variable name for the turtle. Variable name itself is an expression, and a function call itself an expression as well. So this part also an expression. Okay. Yeah. Oh, value itself is an expression. So this 90 is also expression. Okay.
So turtle is a function call, but that call is made in another function, which is draw a rectangle.
Yeah. So we use this function in here, right? In this function, yes. Yeah.
Okay.
Okay.
So begin fill is a function and fill is
Yeah, they belong to turtle package. That's why we use the dot notation here. So begin fill is a function that inside the turtle module. Okay.
And I'm pretty close.
Mhm.
I'm getting like two
Okay.
instead of.
Yeah, because you probably only called. Oh, that. Oh, you didn't see this 90 also. You basically you have over.
Okay, so it doesn't.
Drawn it over.
It
So this.
doesn't turn 90.
See, yeah. So I. No, I. This is not right. This right here. So I have 90, 135, likewise. All right. So next question, guys. What write an expression, use your code in your code. So this is an expression, this value is an expression, this variable is an expression, this whole function is an expression. So there are a lot of expressions here.
So
Okay.
integers can be expressions.
Yeah.
Anything that's not an expression.
This entire line is not an expression, right? That's a assignment statement. Yeah. All right. And write an assignment statement you use in your code. This is one, right? This is one. They're all assignment statement.
Doesn't want to like let me post it.
Surely he has a problem. Okay. All right. So next one, write a statement other than an assignment statement. What is that?
Other than that would be an import statement.
Yeah, we learned that, right? So import statement. So that's another statement type. Okay. All right. Then write two Python reserved words you use in your code.
The reserved words I got define.
Yeah, def. Yep. Def. And yeah, this is also one. And an import also right here is a one. Okay. We're gonna learn it in week 9. For now, we are using it. Okay. All right. So yeah, it's not that difficult, but the concept, the programming concept related to that, we're gonna learn it in week 9. Okay. Yeah. Okay.
Now, are we embedding the code?
Not now. I'm going to save time. I'll do after the class.
But
I'll post my code. I'll post this code. Yeah.
but do I when I
Yeah, you have to both
four
for
questions?
yeah, and then along with that,
Is
yes.
that enough angles, or do you want the whole?
Well,
round?
do the whole thing, right?
Okay.
All right. All right, come on. Did you do it? Did you? Can I see it?
Right here.
All right. Okay. So let's try to draw the next one. We can do later if you want, like to draw the pattern. Okay. All right. Okay. All right. Let's move on, guys. Okay. So yeah,
Wait, what's that last angle? You got 270, 315, 360.
you got it right. Okay. Cool.
Yeah, it's
All
like
right.
this like anime. It just pops up. I don't know why.
Yeah. So the reason why is you all blue, right? Why not red?
I think because it where's my fill color? My pen
Oh,
color.
okay. So the reason is you, even though you pass the color, your actual color is actually always blue.
Right. Oh, you want my fill color to be
Yeah, you
two
can
fill
change
colors.
this blue into this color, and then it will actually alternate. So
So
can you change that
what do you
blue
mean?
to color?
Oh, so the
Yeah.
color. You
Yeah.
can change color to blue.
Yeah. No. You can't do that. So it's leave
Leave
color,
color.
copy that, and then paste it over here.
So copy
Yeah.
color.
Yeah.
And then put that under.
Yeah. Inside that line 11. Yeah.
Like next to it.
Not quotation, but replace the whole thing with that because it's a variable, right? All right.
For
So
both.
now run. Now run. See that?
Yeah. Okay.
See the beauty of passing the parameter. So you already either you had a fixed earlier, you had a fixed color, right? Blue.
Right.
So everything was blue, but even though you call down below, scroll down, you were calling red and blue differently, but you only draw only one color blue, right?
Right.
It's
Right.
because you had fixed value blue in there. So
Okay.
now it's actually different.
That
Okay.
makes sense.
Okay. Okay. All right. Any question? We're gonna move on to our lesson, guys. Yes.
What am I doing wrong?
Okay.
Because he tried to figure it out too.
And didn't work. Okay. Error. So let's read it. Turtle object has no attribute forward in line 12.
That's this one.
So forward. No, it's misspelled, right? FORWARD.
Oh, is that it?
Yeah, that was it.
Oh,
That's not even. That's.
Yeah. So now you
That's
have to
really
change
embarrassing.
all of them. So that it's again there repeated.
I don't know how
Yeah.
to spell the word forward. Got it.
That's okay. There you go. Okay. All right. Okay. So I will post this code. I'll also improve this one a little bit further. So please check my answer, guys. Okay, that's important. But to save time, I'm not going to do it over here now. Okay. Why? So did you use alternating color or just one color?
just one.
Oh yeah. All right, guys. So let's watch our video. So we are starting. We have been writing function and using function for almost couple of days now, right? But all of those were like, you were immersing in it. Okay. Pretty much think of this. I, push all of you guys into water. Okay. So in education, we call it immersion. You may have heard like, Spanish immersion program, Chinese immersion, so Mandarin immersion, right? So, so now we are actually starting this week. We are actually learning functions. Okay. So, and then in regarding that, right? So we use parameters like this, right? Right. So, and this video going to show you the importance of parameters. Okay. So let's watch it, guys. Right here. Okay. Yeah, function parameters. Okay. So I just published it, guys. Could you all refresh the module view? So, okay. So, and I want to warn you, right? So the language this girl is going to use is JavaScript. So you may see some differences, like in the form of syntax, but the exact same thing, the functions that she's going to use is also similar to basically turtles. She's going to use turtles, but in JavaScript. So you will see a different syntax. Okay, just wanted to warn you the difference. But what she's doing is actually exact similar thing that what we just did with turtles. Okay. All right, let's watch this.
Are we still in module 4?
No, this is module 5. This is in module 5. I just published it here. This is the title, function parameters. Okay. All right, so let's watch.
You've already seen that some functions are defined with parameters to make them more generally useful. For example, the original version of move forward moved the turtle exactly 25 pixels. This doesn't give you a lot of options on how to design your drawings. A much more useful version of move forward is one that accepts a parameter that allows you to specify exactly how far forward the turtle should move. Up to this point, the functions we've written ourselves don't have any parameters, but the ability to write your own functions with parameters is both useful and powerful. So let's see how to do it. Here's an example. Look at this function that draws a square with sides that are 100 pixels long. If we wanted to make a function to draw a square with sides 50 pixels long, we'd have to make a new function that's almost identical to the first one, with the only difference being how far the turtle is moving each time. If we wanted even more options for the size of the square, every time we would need to declare a new function. Yeah, that's not very good, but luckily there's a better way. The solution to the problem is the ability to create a function that accepts a parameter. A parameter is a named value that is provided as an input to the function. We saw that our version of draw squared has a lot of code that was repeated. The turtle was executing the same basic behavior, just moving by different amounts. It turns out that we can express this generalized behavior in our code as well. Here's a new version of draw square. Here, we've made the size of the square a parameter of the function. Notice that the function heading declares that it needs an input. We've given a name to that input, and that name is size. Everywhere in the code where we need to use that value, we just enter the word size instead of a number. Writing a function with a parameter is very similar to writing a function without one. Just drag the function block that shows a parameter and drop it into the workspace. We add the name of our parameter inside the parentheses in the function call, like this. Just as giving a meaningful and descriptive name to your function is important, so is deciding what to name a parameter. The name of a parameter should give some insight into what the value will be used for. In this case, we've chosen the name size to indicate that you can set the size of the square when calling the function. As a programmer, what you call your parameter is your decision to make. We can write the body of a function like this. The parameter, size, acts like a placeholder for that value. Wherever we want to use that value, we just refer to it as size instead of a number. Let's look at what happens when the function is called. Now, when a user calls draw square, they call it with a value like this. We say the value of 63 gets passed to the parameter of the function. The parameter acts like a container with a name on it. Whatever value is passed into the function is stored in that container. Inside the body of the function, you will want to use the value stored in the parameter. To do so, you must refer to the value by its name. As the program is running, whenever the word size, in this case, is encountered, it's replaced by the value stored in that parameter. Adding a parameter to our draw square allows us to generalize its functionality. In other words, our function is useful in an entire range of situations, as opposed to just being useful in one particular instance. The result is a function that gives you much more flexibility and control without the need to create duplicated code. Once you've added a single parameter to your function, you might realize that there are multiple aspects of its functionality you'd like to generalize. For our square example, you might want to change the width or, say, the color of the line. To do this, you can simply add more parameters and separate them by commas. You can then use any of these parameter names in the body of your function. When calling your function, you'll need to include multiple values, one for each of the parameters and each one separated by commas. Parameters are another example of how abstraction can be used to solve problems. When confronted with a group of related problems, we first work to identify patterns across all of them. In doing so, you might realize that using parameters will let you define a single function with general behavior that can solve any instance of the problem with one piece of code. This is a powerful skill that removes the need for creating duplicated code and leads to programs that are easier to read, write, and maintain.
All right. All right, guys. So that's what actually we did, right? See that? We use a bunch of parameters so that we can actually draw a rectangle with any width, any length, any color, and also any angle, right? So that's being more flexible. Now we can actually, in that way, we can now draw any rectangle of any size, right? So that's the beauty of writing a function. Now imagine, like, if I didn't write this function, then I will basically repeat this code to draw this all 8 rectangles. I'll repeat this 12, let's say there's about 12, 10 lines, right? Let's say 10 lines to draw this 8 rectangles, then I will repeat those lines 8 more times. So 80 lines of code I would have written without a function. So And then you can see that the amount of the reduction of code that I actually avoided, right, using writing functions. So that's one benefit of it. So in writing function. Okay. All right. So we're gonna start our lesson, guys. Yeah. I'm going to quickly go over, since we are finishing our chapter 4. Not this one, sorry. All right, so this is the discussion one. All right, assignment. Pick one problem and post your solution, and then you will see your friends post and then at least reply to one classmate. Okay, so that's the discussion. And if you didn't participate in Tuesday's class, try to do this one as well. It has extra credit. So the practice code check, it's a similar problem to this one, the programming assignment for this week. So if you do this one, it will be a good practice for doing that one. But it also helps you learn the code, get familiar with code check environment. All right, that's about that. I added these two actually yesterday, guys. Okay, so all right, so let's start with this one. Oh, by the way, I want to show you that, okay, so you guys should take some time to read these instructional resources because I actually, I have my pre-recorded lectures embedded there as well. For example, you will see the slideshow, and then I use this slideshow to do my lesson. So, and that's recording is right here. Okay. So if you want to, grab some of these ideas, in addition to SciBook, I highly recommend watching these videos and running these PowerPoints. Okay. All right, and it's also in our next chapter as well. So every chapter has a one, and in particular, I recommend all of these in programming modules. I have my own previously recorded video. Okay. All right, so let's start our lesson. Okay, so so we have been kind of for now until now, right? So this is where we formally start writing our own functions in Python. Okay, so and then this animation shows you the purpose, and we already saw that in the previous code, right? So I create a function to draw a rectangle and then use it 8 times. So to draw the 8 different rectangles, right? But if I didn't do it, like I said earlier, I will be repeating same set of code like 80 times, right? So I avoided that. And then this animation actually shows you the same. And you can see that over here. So you want to convert Fahrenheit to centigrade, and this is the formula. And then if you do this way, and then you basically repeat a lot of code. But if you do this way, right? So you have a function, and then you basically use the function and call it to get the value. Okay. All right. So it's much easier and also easy to maintain as well. Okay. All right. So this is the definition of function. All right. Function is a named series of statements. Okay. Or I would say name series of code. Okay. So and then if you in particular in our example, right? So this is the name we gave to represent all of these code. Okay, that's the name we gave. So we don't have to reuse that. Instead, we use this name to call that code. Okay, so so that's as simple as that. That's the definition of function, right? So a function is a named series of statement, and then there's few things to two important things to our function. function definition is where we implement it. Okay, imagine like you are the engineer who builds the bread machine. So that's the part of the definition. Okay, the analogous part. Okay, and then in the call we use our function. Okay, so we call it to use it. So like for example, the lay user now using the bread machine the engineer made. Okay, so basically so it's really important to understand these two different aspects of the function, right? The definition, engineer defines it. In this class you are going to define a function, and then you are also going to use it by calling it. All right, so let me show you. This is the definition, right, of my function draw square, draw rectangle, and here is the call, right? So there are 8 calls over here. Okay, so all right, so we I mean we actually started our first line of code on week 3, right? On hills, right? So we use print, right? That's a function, right? But we didn't define it, right? It was given to us by print is given to us by Python, right? So that's why we call them built-in functions. But we call print, right? Print quotation hello world. So we called print, right? So so we have been kind of using it from the get-go functions. So this is the first time we are actually formally defining our own functions. Okay.
So hello world is the parameter.
Yes. Yep. You're right. Hello world is the parameter that we pass to print function. Okay. All right. All right. So the syntax is basically we use the def keyword. So it's the specific keyword that in Python that we need to use to define our own function. Okay. All right. So let's go to our class code, guys, and I'm gonna work out an example. All right. So let me go to add. All right, it's Thursday. All right. Okay. So I'm gonna create a let's write a function, simple function to let's say get square of a number. Okay. So you guys can follow me. Okay. So def. So I'm gonna directly write the code, guys. Okay. So get square. All right, and it takes a number, right, and it's actually gives you the square of the function. So I'm gonna write my doc string, you know, calculate square of UARE of the number, right? So what do we call these two lines? This line 1 is a doc string. Both of them together we call we learn a different name. The public interface of the function, right? So anyone who read these two lines should be able to get a clear idea of what the function does. Okay, so that's why the name is important, and also the line below that, the docstring, is also important. Okay, so all right. Okay, so this one is simple, right? So I'm gonna basically give the square, right? So I'm gonna print it. Okay, print the square, right? So let's try that. So you, to get the square, right, so basically do this, right? You can also use the this symbol as well. So this is the power symbol in Python, so power of 2. Okay, but I'm gonna use this one for now. Okay, all right. Okay, so let's check this function now. All right, so I'm gonna go to sorry. All right. Oh, one thing, guys, I have these code lines. Okay, and if you, if they are not showing in yours, this is how you to do it. Okay, so settings. All right, and then go to editor, and then click on this checkbox, and then it will show you line numbers. Okay, all right, so you don't have to explicitly type them. Okay, I saw this in previous class, that's why. So I already have checked it, so that's why line numbers are showing in mine. Okay, all right. Okay, so to use this function, so I'm gonna call this one. Okay, and right here. Okay, and you can see that, right, I actually came out of function. See that function is, inside, so indented, right, function code. Then now I'm in outside. Okay, so this is like similar to I'm running it in the main program. Okay, even though you don't see the main there, right, I'm running it in the main program. Okay, so let's run this one out. We'll get oh sorry, I need a number, right? So let's say number 2. Okay, I got 4, right? Okay, so I got the answer 4. So now imagine right, so I'm gonna do this way. I'm gonna yeah, let's see, yeah, let's I'm gonna call this function again. Okay, for the value of 2 now I got, right, so I got 4 by passing 2, right? So I'm gonna pass it again, right, and see what happened. Okay, so I should get 16, right? Am I not? Right, because the first call I get 4, then I am passing that 4 to the function again, so 4 times 4 should be 16, right? So let's see what we get. So it didn't work. All right, why it didn't work?
Maybe it's not saving the answer in memory. I mean, you didn't use the multiplication symbol.
Well, the thing is, see that I got 4, right? So that means I'm basically, instead of this line, you can imagine you have 4 there. So it should give me 16, right? But it is not. Yes.
Not actually attributing the first or the parameter call with get square to anything. You're just printing it.
Yeah. So that's the reason, guys. Okay. So basically, what happened was there was no value returned from that function we wrote. It just, put it in the screen. That's it. So value 4 is only appearing in screen, nothing, no value there, right? So basically, this doesn't return anything. This just printed to the screen. Okay, so there's a problem, right? So the fix is actually the return statement. We're gonna learn just now. Okay, so but I'm going to show you what actually it's actually why the print does that, right? So I'm gonna print. Oops, sorry. Print. Let's say hello. Maybe no, not just a number. Let's say 10. I'll print 10, right? Okay, so I'm gonna now print the result of this. So I'm gonna put that inside in here. Okay, and see what we'll get. See that we got none. So this 10 is result of this line, this 10 is result of this inside parameter, right? But this one is the whole line, so it's actually none. So that means print function doesn't return anything, it return none. All right. So I want to, this is a really important topic, because for beginners this is really puzzling, because when you use print you see the value in the screen, right? Then you tend to think, okay, that's the return value, or that is not actually. The return value is actually none. Okay. So, and this is the proof, print returns none. So there's no tangible thing, or there's no value to the outcome of print, we just see it on the screen. All right. So then what we have to do is we're going to rewrite this function with return. Okay. So I'm going to type the same code and then in the different block. Okay. So and then instead of printing, I'm going to return the value, and you will see that it now works. All right. So all right, see that I got 16. Okay. So I think I have to print my call, otherwise that's why I didn't see the value of this one, right? So whenever you actually use return, make sure you have to print your call to your function. Okay. So this should be get. All right. So you have to do this as well. Okay. So I will now see 4 and 16 both. Okay. All right. So just because print actually prints the value and you see the value doesn't mean that it will not return. So that means if your function must return a value, then do not print it. Use return keyword and return statement. So now the third statement that we're going to learn today is the return statement. So this is the third type of the Python statement that we are learning today, the return statement. Okay. So and that's what we have over here. Okay. So the return statement. Okay. so that way we can use the call to a function in another function as well, like what we saw, right? So like right here, right? So we use this call and use it again in the same function call as a value to the parameter. Okay. All right. So it's again, guys, this is really common among beginners. Okay. So if you again remember, if your function must return a value, do not print it in your function. Instead, use return that value. That's it. Okay. So see that what I did? Return that value, right? The square. This is the answer. Yeah.
How did the parentheses work on that? Because I'm getting an error message and I'm not sure.
All right. I need help, guys. TS. Okay.
Sorry.
All right. You can simply raise your hand and then yeah. All right. So let's continue. I think we can try to finish this section. Maybe. Yeah, I think. So we already gotten used parameters, right? So there are two. I mean, based on the way we use them, the naming is different. Okay. So we call the parameter in the definition. So in our code over here, these are input parameters. Okay. All right. These are input parameters. In our call, these are arguments. Okay. All right. So the respective in actual inputs in the call are called arguments. There's another name called for that. So so again, guys, these are again terminology really important. Okay. We call these parameters, or more specifically input parameters. We also call these formal parameters. All right. formal parameters, and we call this arguments or actual parameters. See that they are the actual values that we are passing. So, they are either called actual parameters or arguments, and these are called just parameters or formal parameters. Okay. All right, those are terminology, guys, really important. Sometime in interviews they ask to test those knowledge. Okay. All right. You can have either no parameters, you may have some, imagine like, so sometimes there may be a function that you do not require an input, right? So sometimes that scenario there, right? So you don't have an input but you do something, right? So there are real world analogs to that as well, if you think, right, a little bit deeply, right? So right, so but there can be multiple. I think in our function we had, like, there was 4 parameters, right? Right. But if you think of this field color, see that function doesn't have any parameter, right? So it actually does its thing without taking any input. Okay, that's as simple as that. Okay, but this function is belong to turtle module, right? That's why the dot notation. Okay, all right. So let's continue. All right, you can call a function within inside, so we're going to get into that. So let's stop right here, guys. Okay, and hopefully we can finish this module next week. By the way, guys, next week Tuesday we don't have a class. You guys know that, right? Why? Lunar New Year. Okay, so it's a
What day is this class return?
we are returning on next week Thursday.
Is there class Wednesday?
Oh yeah, but we don't meet on Wednesdays, right?
But okay. Yeah,
But you have, if you have a class on Wednesday, you have a class on Wednesday. Okay,
Tuesday we don't have class.
just Tuesday we don't have. Monday also, Monday, Tuesday. So it's for you, like, for us City College employees, and for you guys it's a 4-day long week, 5-day long. I don't know. Yeah, 4-day long week. Yeah. So yeah, so it's so Monday is President Day, right? And then Tuesday is the Lunar New Year. So the district decided to give that as a holiday. And it started this semester, I think. This didn't happen last year, right? I don't recall. Yeah. Yeah, probably the city's influence, like, it's a good thing, I think. Yeah. All right. So
I do have a quick question.
yeah.
You said this when the class started, but I did fall behind. I tried to do this iBook and I just could not do it. So I'm behind on the due dates, but that doesn't
That's
necessarily matter. I can just catch up.
No, yeah. So one thing I want to explain: if you miss the deadline, Canvas is going to auto grade with the 0. But we're going to come back and evaluate your values, your submissions, and regrade them. So don't worry about them. Okay. But as designed, in there is a deadline, and then if you miss the deadline, Canvas is going to auto grade with the 0. So that as designed. Okay. Yeah. But again, there's no enforced deadline in this class. That means you will get your submission worth for, right? Okay. Other questions? So we're gonna start our topic today. Yeah.
I remember last week you mentioned something about presenting the midterm project.
Yeah, I'll be opening the midterm project this week. So let's say by tomorrow. Yep. Yeah. So, but you will have until mid-March to submit them. So you will have enough time. I'll make sure you get a 1 month. And again, that one also I don't recommend, but again, no enforced deadline. Okay. So all right. No, this one, sorry. Okay, so let me publish it, guys. Yeah, this one, equilateral hexagon. Okay, so I just published it. It's in module 5, guys. Okay, so refresh your module view, equilateral hexagon. Okay, all right. So read the problem statement. I rearrange it a little bit so that you guys, I put the problem prompt and then like that. So okay, so read it first and then pair up and then do it. Okay, so try to get together and then derive the algorithm. Okay, first.
It's just a square that sits there. So the first thing we need to do is
All right. Yeah. Can you guys help me? All right. Yeah. So what happened today? So you missed the first half of the lesson. So but did you got it? Did you get the solution?
solution for the previous one.
Yeah, the one that I did it with the class.
No,
Okay.
I looked at it, but I wasn't gonna watch like the lecture.
Okay, yeah. So you can watch it as well, and today after the class, I'm going to post it my solution. Read it and then play, like you can run it and then read it, and then what you can also do is understand it, and then you can type your own like code. That way also work help. Okay, all right, try to do that. Okay, all right. What happened?
Just I couldn't find it.
Oh, okay. It's in module 5. All right, guys. Hope you guys can derive the algorithm at least. Okay.